So here we go. Okay. First thing I'm going to do on number 6, this is in the warm-ups, by the way, if you're looking for the page, it's the one right on the back of the stamp sheet that says warm-ups. I'm going to put the n over 1, and then I'm going to look at the numbers 1, 3, 9, and 6 and decide what number do they all go into evenly. Into, not into them. 18. Okay, so I'm going to multiply. I'm going to multiply 18 to the tops of all of the fractions. Multiply 18 on the numerator. I got the calculator today because some of these are big. So 18 times n is 18n minus 18 times 1 is 18. 18 times 19 is 342. 18 times 5. Okay. And this is kind of the moment of truth. I'm going to see if I did it correctly. When I divide these fractions, they should come out to whole numbers. So 18n minus 6, 342 divided by 9 equals 38 minus 90 divided by 6, 15n. Yay, whole numbers. Okay, and as I said yesterday, I like to pick the one that has a letter on it and is the smallest, and I undo that one first. So add 15n. Add 6. Divide by 33. Okay. Does anybody know a number that goes into 44 and 33? 11. Yeah. And I'm going to show you the first graphing calculator trick today. So if you don't have one, get one from underneath the window over there or get yours out. Okay. Here's your first fun graphing calculator trick. And I'm not gonna know how to do it on yours, but we can Google it. Okay. So you're doing a problem like this, and you get down to the end, and you know you need to divide both sides by 33. So you usually go in the calculator and divide, and it comes out to a terrible fraction. I mean decimal. Okay, so you say to yourself, Mrs. Talbot said that if the problem starts in fractions, my answer should be in a fraction, but I got a horrible decimal. What do I do? Okay, your graphing calculator is wonderful. If you hit the math button, which is located right underneath the alpha, so it's the third one down over here. So hit the math button, and then right there is change it to a fraction mode. So you hit enter, and then hit enter again, and look at the beautiful reduced fraction. Yay. Horrible decimal, very nice reduced fraction. And that's what I call math enter enter. And so math enter enter will be your new friend. Might be the best thing you learned today. Okay. Square root of 18. 18 is 9 times 2. And 9 is 3 times 3. Pair of threes, so I circle one and cancel the other. The circled 3 comes outside, and the leftover 2 stays inside. You guys have any questions about number 6 or 8 before we move on? Okay, can you guys find the page that says domain and range warm-ups, please? Okay. Um, this is something that's really important for Math 3. You haven't done it since the first semester of Math 1, probably. It's been a really long time. And it's hard. You might not have even understood it at all during Math 1. So I am going to do 2 of these a day to try to like spread it out over time to try to get it to sink in for you guys. Because domain and range is not going to go away. So we are going to just do our best to make this make sense. I like to use a colored pen or some kind of color while I'm doing these problems, these domain and range problems, because I think the visual is really helpful. And what I need you to do is when you're doing domain and range, you only write on the axes. Okay, first thing I need to remind you is that domain is the x-axis and range is the y-axis. And I remember that because domain and range is in alphabetical order and x and y are in alphabetical order. So also we never say range and domain. We always say domain and range. Okay, I'm going to take my colored pen and I'm going to write on the x-axis where this graph exists. It only exists here and here. Can you guys tell that the graph only exists in those 2 spots on the x-axis? Okay, so the way we write it when it's dots like that, we just say x equals -3 and 2. The domain is only -3 and 2. Okay, now for the range, I'm going to draw on the y-axis, and I notice that this has an up arrow going forever, so I'm going to bring that over to the y-axis, and I'm going to follow this arrow down to here. So the graph goes forever up and then comes down to here, and then it starts this one and goes down forever from that arrow. Does anybody remember what it's called when you cover the whole axis? All real numbers. It's all real numbers. And then because I'm a lazy human, I write it with a fancy R. So my R has 2 stems. Okay, last thing, whether or not it's a function. For whether or not something's a function, we do the vertical line test. You draw vertical lines on the graph, and if any of your vertical lines touch twice or more than once, it is not a function. Can you guys tell that if I drew a vertical line on this arrow right here, that I would actually hit this arrow an infinite amount of times? Can you guys see all the little coordinates I made? Okay, this is failing the vertical line test and it is not a function. So you say no, fails vertical line test. If this is hard, it's okay. We're going to do it slowly over several days. It's just that important. Okay, number 2. X, Y. Okay, the farthest point to the left is here, but it's open. So on your axis, kind of try to make that obnoxiously looking open. The graph goes to here, to here, to here, to here, to here, and ends closed. This type of graph, the way that x-axis looks, I will refer to this as a Baymax graph. I know that's silly. You guys know who Baymax is? Okay. Yes, exactly. So I know one of them is open and one of them is closed in this, but when I have a Baymax style, which means I have 2 points and a line between, you write the domain in a compound inequality. So you say -5 is less than x is less than or equal to +5. You go from left to right. This means that it's open. This means that it's closed. Okay. Now, the y-axis, I can tell that it starts up here at 2, and it goes down here to -2. But my question is, does it actually touch -2 anywhere on the graph? Does any part of this graph actually touch -2? Yes. It touches it here and here. So the graph actually touches somewhere at -2, so that's closed. It touches this whole line and that closed dot. Okay, so -2 is less than or equal to y is less than or equal to +2. So this goes least to greatest and then closed, closed. Okay, now draw your vertical lines in. Do any of these vertical lines ever hit the graph more than once? No. So this is a function. Yes. Passes vertical line test. Don't worry, we're going to do lots more of these. It'll all come back to you. Domain and range is hard. Both of my kids, when they were in calculus, would ask me questions about domain and range. So it's just not easy. Okay. Now I want to share with you the Google Classroom post I made this morning, which is right here. And I want to talk about the fact that we have a quiz tomorrow. It's 3 problems, and it's things from Math 1 and Math 2 from that review worksheet, but I narrowed it down to the 3 things that I care about the most. The first one is factoring a quadratic. That's box and diamond. And you might have to look to see if you can take a GCF out first. Do you know what I'm talking about when I say those things? Okay, so box and diamonds. Also notice that it says there's no calculators. I want to tell you 2 things about that. First, we did not make the numbers really big, I promise. Second, we're very, very nice and generous on mental math mistakes when we grade it. It'll be like -0.5 point, not a big, it's not gonna make or break you if you make a mental math mistake. It is okay. Just have to get used to, not relying on the calculator all the time. Okay. The second one here, graphing a line, finding the x and y intercepts, and rewriting from standard to slope intercept form. I'm a little bit scared that you guys don't know how to do that. So I'm going to do one of those with you from your tonight homework. And then solving a 1 variable equation, that's just a regular like distribute stuff on both sides, solve for x. Let's look at the homework for tonight so I can make sure that you see the topics. Gonna do a few of these problems together, just get a couple of them started, just because I want you guys to be prepared. I'm hoping everybody does really well. Okay, number 1 and 2 say factor the common factor out of each expression. Can you tell in number 1 that they have a 3 in common? GCF of 3. Okay, so you put a 3 on the outside, and then negative 3 plus 2x squared. Final answer. That was all you had to do on that problem. Same thing for number 2. Just find the GCF, factor out the greatest common factor. Are you guys all okay with number 1 and 2? Okay. Number 3, I'm not going to do. It's regular old box and diamond. But I do want to talk about number 4. Do you see how, first of all, there's a GCF of 2, but do you see how the front is negative? It is my advice that when you have a negative in the front, you factor out -2 and not +2. And the reason is because the diamond and box is so much easier to do with a positive than it is a negative. So what I would say to start this problem would be take out a -2. That changes this to -2. Nope, 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 nope. The minus b. And changes this to -56. So when you take out the -2, it changes the sign of everything and divides by 2. And that, do you guys see how this is a much easier diamond? Okay, now I want to do number 5 together. Are you guys okay to finish the box and diamond for number 4? Yeah, okay. 2 people will speak to me, so that's good. That's good. Okay. So on number 5, we're going to do this whole problem together because I don't know if you guys had Mr. Knight. He did not do difference of squares at all last year. So if you had Mr. Knight, you probably, this doesn't even look familiar at all. So I just want to make sure that I go over it. First, can you tell that there's a GCF of 5? Okay, so we're going to do that first. And then you're supposed to recognize that this is called a difference of 2 squares problem. What I mean by that is this is a perfect square, this is a perfect square, and it's a difference. You might never have seen this before. It's okay if you have it. By the way, this is not the type of factoring that's on your quiz. It's just regular box and diamond. So don't worry if this is very, very new for you. Okay, so what I like to do is I like to take the square root of that and in a little factor tree and make that n and n. And I like to take the square root of this in a little factor tree and make that 8 and 8. Then I put the 5 in front and make 2 parentheses. I put the n's in the front seats of the parentheses. I put the 8's in the back seats of the parentheses. And one of them has to be positive and one of them has to be negative in order to multiply to get a negative right here. Now, why does this make sense? It makes sense because what is positive 8n plus negative 8n? 0n. That's why there's no n term in the middle because they cancel. So that's why this works. Anyone want to ask anything about this? Is that helpful, I hope? The hardest part about these is just recognizing them. It's not hard to do. It's just like that switch has to go on in your brain to be like, oh, this is a difference of 2 squares problem. Okay. Now, let's do number 7. And I'm going to do number 7 backwards. I'm going to sketch the line first and then find the X and Y intercepts off of my graph. So I want to remind you how to graph a line. You start with the y-intercept, which is, so it's mx plus b. B is 4. So go to 4 on the y-axis and make a dot. And then the slope is -1. So that means you go down 1, right 1. And there's your line. Okay, now we're going to talk about the definition of x and y intercept. The x-intercept is the coordinate that is on the x-axis, which is 4, 0 in this case. And the y-intercept is the coordinate on the y-axis, which is 0, 4 in this case. Okay, and then the last problem I want to do with you guys is number 9. So if you could flip to the back. First, wait, let me ask. Hold on. I forgot something. On this one, do you see how it's a negative in the front? I would make it this. Personally, you don't have to. You can do the box and diamond without doing that, but I find the box and diamond is easier to do if I take that out. It's up to you. Just a hint, just not a hint, just a recommendation. Okay. Now, anything, are you guys completely okay with the front page? Okay. All right. Now let's go to the back page. And I'm not going to do any of them from 11 to 14. I'm hoping that everyone's got that. If you want to ask me anything individually, go ahead. But I'm hoping that everyone's got 11 through 14. But I do want to do number 9 with you because that's the one where it says find the x and y intercepts, rewrite into slope intercept form, and sketch the graph of the line. This is the one that's like the one on the quiz. Okay, there's a problem though, is that this particular problem has a typo in it, Evan, which I told you I was going to make sure that you knew there was a typo in it. He was already working on this yesterday, so I felt bad after you went home and I was like, oh no, I forgot that there's a typo in this problem. It's not equals 12, it's equals 6. And if you try to check your answer, the answer matches for equals 6, not equals 12. So if you tried to do this one already, yeah, it's not you, it's me. Okay, but anyway, so find the x and y intercepts. To find the x-intercept, I will let y equal 0. You guys are going to learn that I'm one of the laziest people in the whole world. When I let y equal 0, I literally just cover up the y with my finger. And then I say, okay, if y is 0, then x is 6. Did you guys see what I did? I call this the cover-up method. Okay, and then I can leave my coordinate 6, 0. 6, 0 is right here. Okay, now the y-intercept is where you let x equal 0. And you cover up the x instead. And I have 2y equals 6, y equals 3. Zero, 3. 0, 3. Okay, now the last bit of this problem says rewrite into slope-intercept form. That's the last thing I'm going to do. X plus 2y equals 6. This is called standard form. And to rewrite to slope-intercept form, I'm going to get y by itself. So I'm going to subtract x from both sides first. And because you want it to look like mx plus b, you want to put the x thing in the front. Okay, and then divide everything by 2. Okay, now this slope looks really weird. Negative x over 2 looks like a really weird slope. What I want you to remember is that x is 1x. So this is y equals negative 1/2 x plus 3. So put a 1 in front of that x and then make that a fraction for the slope. Okay, now here's the best part about this problem. If you do the x-intercepts, graph them, and make your line, you can use that to help you verify that your slope-intercept form is correct. So this would be up 3, and then a slope of negative 1/2 would be down 1 over 2, down 1 over 2, down 1 over 2. This is one of those problems where you can check yourself to make sure that you're correct before you leave the quiz or test. Okay, do you guys think that you know how to finish the rest of this page? And do you understand what the 3 topics are? So one of them is factoring. There might be a GCF at the first part, but it has its box and diamonds. Second one is this exactly, like those 3 things. And the third one is solving one of the equations, just like 11 through 14. Okay. All right, now I need you to, for the first time, get out your notebooks, please, or a piece of graph paper if you don't have a notebook yet. While you guys are setting this up in your notebook, I am going to bring your group 4 function machine. If you guys need graph paper, there's some on the table right here under the window. Okay, so number three has two parts and it's a puzzle. I have to be honest and tell you that I think part B is actually easier than part A. So I think we should start with part B. So ignore part A for the moment until you understand exactly what's going on. We'll do part B first. Okay. So I gave you 4 function machines. Take a look at them. Go ahead and spread them out. Your job is to put them in the correct order so that when you put in 64 into the first machine, at the very end, the last output you get out is 131,065. Okay, so you're going to put in 64 into one of the machines, and you're going to get an answer, and you're going to drop that into the next machine, and then get an answer and drop that into the next machine, get an answer and drop that into the next machine, and then the answer should be 131,065. Your job is to move the pieces around to figure out what order the 4 need to go in. Now, I can give you a hint. Take a look at your machines. What machine makes the most sense to plug 64 into? Anybody know? Other than, yeah, that one. What's the square root of 64? A nice whole number. Okay, so I'm gonna give you a hint. Your order is going to start with f of x equals the square root of x, which is going to be square root of 64, which is 8. And then you have to figure out, then you're gonna use the 8 now and figure out which machine that goes into next. And also notice that the ending is a really big number. Which one of the function machines is going to give you a really big number? So you can tell which one's the start, you can tell which one's the end, then you have to figure out the 2 in the middle, yeah. Okay, while you guys are working on this, I am going to, okay, so once you get that one solved, which will be quick, then try A, which is a different order where you start with 6 and end in 11. And while you guys are working on this, I'm gonna come stamp anybody that I didn't stamp yesterday. I stamped a bunch of people yesterday.